You doing? This is me. I'm getting ready to do my final. Got questions over here and answers for them. Okay, so let's go here and let's pull up the final project. And that's this. And let's go down here. I mean here. Rather go here. I'm sorry. We're gonna move this up. Okay, and let's go down here. Let's clear everything out. CLF. And let's go ahead and discuss. I'll move this back down here. And we're going to put this over here. And we're going to put this down. I think. Yeah. Okay. And we're going to go up here to the deliverables. Okay. So I'm supposed to create a short 3 to 5 minute video walking me through your project. Use screen recording tools. Okay, I understand that. Okay, so explain the dynamic event engine and discuss how you implemented specific start in your simulation. Okay, so I'm gonna go over here. I'm gonna pull up the questions here to answer all the way up to the top. Okay, so over here, I'll move this over. This is basically me answering all of that. Okay, so let's go. Wait, where to go? Let's go. There we go. Okay. So let's go to the top. Let's look and find it. The simulation class implements what we call the dynamic event driver engine. Here's the key idea: the event driver engine, so the rather request, right? Okay, so I'm gonna open up this. We'll go up to the writer requests, is right here. Car, and all that. So that's the quad tree, the simulation. Okay, here we go, right here. Uh, node right there. Okay, so here it is. The writer request. What it did, it generated uh at random different riders and points upon request, different points or locations upon request. Um, it did it also for the here the writer requesters right here. Did the same thing here. Here, okay, and it says what it did was it found the nearest cars. Okay, and then used the graph, which is I'll show you that in a minute. Using the vortex, using the nearest vortex matrix, we found the writer and we picked them up and we dropped them at the location, and then we come down to the pickup code, which is right here, and it has the time that we picked them up, location, and status if the car was available or was en route and did the drop off, and did that for all the cars. Location. Oh, sorry, I used my pointing at it. Um, and then we came down and we did the stop. I mean, the start and the finish of each time, and then the best car for the trip. And like I said, the locations we did for pickup, we did the I'm sorry, we did location. The status of the car was en route or drop off. The pickup time, and then here we had it. The status of the car was available. And we printed everything. We got the duration of how long the trip took. Okay. So let's go back up. Let's do the next question. Where is it at? Here it is. Okay, and the next question says, walk through the dynamic ride generation code and explain why you made the choices you did regarding how riders are generated. Put it in here somewhere. I'll put it in here. Gotta go back up. I don't know I passed it. Dynamic event overview. I got the ride in here somewhere too. I had to copy that in. Dynamics. Classic. No, 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 no. That's the quad tree. No, it's right here. Okay. Okay, so what we did was when we pull it up again. Hold on, pull up the code, pull up the code, pull up the code. Okay. So when we chose riders, we did it at let's we're gonna throw let's make it up bigger. Okay. The graph. All right, so when we chose the rider, we came down and here we go. Rider's request starts. So no, keep going, keep going, keep going. Give me a second. I'm gonna get to it. Simulation stuff. No, 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 no. And run handle rider. Exception rate. Pickup. Okay, so what we did was in order to choose the rider and whatnot, we ran by simulation of a time or in real time using the real time. We ran the closest to the time that came up for pickup. So basically, what it is like so when it runs, we run in real time. When I show it, it'll show you in real time, the time. And then what we did was each rider that came through, each time that was close, we picked that rider up, and we eventually took that rider. And once it was in, it became busy, so we ran another simulation. And for the next person that came up, it came closer to the time that we ran the simulation for pickup. And here that part goes right. That's car position. Yeah. Pick up, drop off. Right here. Right here. Right here. Here's to the vortex. Then we ran the Dijkstra algorithm. I'll drop off arrival, pick up, handler, pick up the rider. Because this shows, all right, here we go. The pickup time. Self-time. So that means anyone who came out. So when we run it, we'll run in real time what the time was, and then anyone came close to that time was the first rider. We picked that up, and then after we picked them up, we ran it again, and it did the same thing over and over. All right. So the next question says. Highlight the integrated Dijkstra and quad tree classics. Display it, upload the usage of include the data structures. MIP map. Okay, so I'm going to show you that. So this is the MIP map, the map SVC. This is the FCC map. These are the coordinates for that. And then in the program, for the Dijkstra program, we came up here. It's here. Trust me. I put it here, so it's here. Simulation, quad tree. Or here we go, the extra. Go some more. Make sure that's yeah. Okay, so the Daxtra runs the heap Q program, the heap Q pop, and basically this is the finding the shortest path. Okay, so now we ran that to compute the shortest path between two nodes using the Dijkstra algorithm. What we did was we basically went down to the quad tree, which is right here. Simple spinal look. Okay, we inserted the points which were on the map here. Oh, that was it. That was it. We can show it right here. Right here. Oh, this is one of them anyway. And what we did was the closest points, which is 4 here. And I think it's just 7. And then we came up, we had 6, which is, I want to say this is 1, 0.1. These are cars, and these are the graph nodes. These are the closest. These are the closest. The closest, oh, that'd be 0.0. This is the origin point, though. And what we did when we came over to the graph, we clicked in those points. Here's the Dijkstra. We clicked in those coordinates. We came down, we plotted them in the quad tree right here. And then we went up and we ran it. So what I'm gonna do now is I'm gonna run it and show you how it goes. Here we go. I'm gonna pull this up so we can I'll get a good look at it. I'll go back up. Here you go. We have the cars that were dispatched, the route that it took, the time that it took, which is 00, the origin time, and it was car 2. We ran car 2. And then we ran route 1, picked up and dropped off. And then at that point in time, we came up with a new rider. NET time was what, 1 minute or 1 hour? I'm gonna say that's an hour. We picked up and we dropped off and did the same thing. And the simulation finish was time was 53.25, 53 minutes and 25 seconds. And that's how we ran it. Okay, guys, I'd like to thank you for putting up with me when it came to doing this final. Uh, it 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 was it was interesting. It was very interesting. What I'm gonna do now is I'm gonna go on GitHub. I'm gonna put everything on GitHub, and thank you guys. It's been a good journey with you guys. I hope to see some of you guys out there. I see you guys on the other side of success. Thank you. Goodbye. All right. There we go.